Today we are going to talk about wet bench, wafer to wafer, with gap effect and phase effect. First of all, we'll talk about phase effect. We have the two lots of wafer. This is a wafer holder. We have the two lots of wafer here, and the wafer optic surface is here. So the optical surface face right. Then we use the wafer holder, this one, to make it rotate 180 degrees. Just one lot of the wafer turn. This lot turn. After rotating movement, the wafer optic side surface now face to face. And what's the effect of it? We will have two lots of wafer in the chemical tank, and just like this one, the wafer optic surface just both slot to the right side, and according to the chemical tank is a sealed environment. The right first piece of wafer is the back side, and this one is the optical side. The direction will cause the uniformity different from this slot with this slot. This slot is different from this slot. So to improve it, we change one lot optical surface direction. Then these two lots in the tank, chemical tank, face to face. So now the result, the same flow field of the chemical tank. We got the same uniformity with two lots. And a gap effect. A lot of wafer. This is the wafer. Put on the wafer holders, holder A and the holder B, and the distance between wafer and wafer, this distance is D. Then the wafer holder B carried the even number of the wafer down. Even number, number 2, number 4, number 6, number 8, number 10, down. And the A wafer holder left the odd number of the wafer, number 1, number 3, number 5, number 7, number 9. And the distance between every wafer now became 2 times of D, 2D. This distance also 2 times of D, 2D. Is bigger than 1D gap. And the wafer holder B keep to move right and up to combine with wafer holder A and B now together, and lay the wafer B together again with 2D's bigger gap, with the bigger distance between every wafer. Then lay together to the chemical tank to process. While we make the bigger gap between the wafers, the wafer gap narrow. You can see that less chemical flow between the wafers, so the less reaction of the chemical. If the gap wider, is a much more chemical flow through between the wafers, so chemical more reaction with chemical. So we have a bigger gap is more reaction of the chemical. It can increasing the throughput we talked about before, and short the process time we talked about before, and most important, to increasing the uniformity. Increasing the throughput, shorter the process time, and increasing the uniformity with bigger gap. Okay, let's all see you next time.